Okay, this is Dr. Williamson, and I'm going to do this particular problem where we determine the rate law for this particular reaction. And it says for the reaction 3A plus 5B goes to 4C. It doesn't matter what the chemical reactants are. We want to determine the rate law. R equals K, A to the M, B to the N. We want to determine the values of M, N, and also K, the rate constant, and its units. Okay, first thing, M and N do not come from the coefficients in the front, the 3 and the 5. M and N are determined experimentally from this data right here. Okay, so we're going to do that. So what happens is some chemist or chemical engineer takes 0.1 molarity A, 0.1 molarity B, mixes them together in a test tube, and measures the initial rate of the reaction and finds that the initial rate happens to be 5 moles per liter per minute. The chemist then does a second experiment where it keeps the concentration of B constant but varies A to be 0.3 molarity, mixes it with 0.1 molarity B, and gets this result. And then varies experiment 3 and experiment 4. First thing we want to do is see if we can figure out what the answers are by inspection. Okay. And if I look at experiment 1 and experiment 3, if I double the concentration of B and keep the concentration of A the same, the reaction rate doubles. That implies N is equal to 1. Okay, now we're still going to have to calculate it the way I taught you guys how to calculate it, but that implies that. Okay, so by inspection, we got N equals 1 by inspection. Now let's take where we keep B constant, say experiment 3 and 4, keep B constant. I could have done 1 and 2, but I keep B constant, and here I triple the concentration of A, and the rate of the reaction goes by a factor of 9. So I tripled the concentration. And went by a factor of 9. That implies to me upon inspection that M is, if I'm doing it right, I hope I'm not having a brain fart here. That implies M is 2 on inspection. Triple the concentration. How do I get 9? That's if M is 2. Okay. Well, let's try and, ooh, I did not want to erase all that. Okay. Let's try and do this now. Ooh, good night. I do not want that to happen. Okay. Don't want to erase all my data. So let's now calculate it. So let's do experiment 3 over experiment 4 over experiment 3. And what's going to happen is the rate constants are going to cancel. And the concentration of A is going to be 0.3 molarity here. The M and 0.1 molarity to the M. And the concentrations of B are going to cancel out. So I'm going to do this. Concentration of B. I'm going to do it sloppy to the N, to the N. I don't know what N is, but I know it's going to be the same number, so that's going to cancel out. So it's a little bit sloppy because I'm writing with my mouse. Guys, I'm writing with my mouse because I can't get my tablet pen to work. But what I'm going to end up with when I do the math is I'm going to end up with 90.0. The units of moles per liter per minute will cancel out, and I will have 10. And again, the units here will cancel out with the units down here. That'll be equal to 0.3 over 0.1 to the lowercase m. The capital M, molarity, will cancel out. Remember, the molarity is supposed to look like the capital pointy M. And the exponent, I'm not doing a very good job, but the exponent at the top is the curly roundy M. Now I take the log of, see, 90 divided by 10 is going to be 9.0. And I'm going to take the logarithm of that, log log. That'll be equal to m log log. 0.3 divided by 0.1 be 3.0. So I'm going to have m is going to be equal to the log of 9 over the log of 3, right? And getting my calculator out to make sure I don't do any brain farts, but I should get 2. Go clear log of 9 divided by log of 3, and I get 2. Okay. And then just to make a point, this stuff right here is what I want to show professor on the test when I show the math. Okay, that's what I got to show the professor on the test for the math. If you just do by inspection and write the stuff down, you're not going to get the partial credit, because I told you guys on the test, I'm wanting you to show me the skill set of the math. If you don't show me that, especially when I told you in lecture, that's what I'm looking for. If you don't show me that, then you're for sure not going to get the points, okay? Because I told you well in advance. So that for sure now I got M as 2. All right. Let's try and get here now. Let me see if I can erase this stuff faster. Boom. Boom. Right. Let's do the same thing now for getting n. So to get n, I want to keep a the same. So I'll do experiment 3 and 1. So rate 3 over rate 1 will give me, I already know the k's will cancel out. The A concentrations for experiment 3 and experiment 1 will cancel out, and the k's will cancel. And I'll be left with here 0.2 capital pointy M to the N, 0.1 molarity to the N, and rate 3 over rate 2, that is going to be 10.0, and that's moles per liter per second over 5 moles per liter per second. But like I said in the previous problem, we know that those units are going to cancel out. 10 divided by 5 is going to be 2. I'm going to take the log of that. That's going to be equal to the log, excuse me, before I get there, let's just go 2 is going to be equal to 0.2 capital M, 0.1 capital M to the N. The M's cancel. That's going to be 0.2 divided by 0.1 is going to be 2. To the N. I know N has to be equal to 1 because I've got 2 equals 2 to the N. The only way that works is if N equals 1. Yes, you still have to do the logarithm to show me that you know the skill set of doing the logarithm math, right? And if you're thinking, why do I have to do that? It's redundant. It's, it's obvious by inspection. Great, then it's easy points for you, but I still want you to show me the skill set. So you're going to go log 2.0 is equal to, when I take the logarithm of this, the log of 2 to the N is equal to N log of 2. That means N is equal to the log of 2 divided by the log of 2, which of course N equals 1, which we confirmed that. Yeah, I want to see all this stuff. I want you to show me this skill set, even though it's redundant and easy in this part. Instead of thinking of it as, oh my gosh, he's making us do redundant, easy stuff, think of it this way. Hey, he's giving us points for doing redundant, easy stuff. Look on the bright side, okay? But it's this skill set, knowing that log of 2 to the N is equal to N log of 2, and so on and so forth, okay? Now we have to get the value of K, the rate constant. You can choose any one of these experiments. I'm just going to go ahead and choose the first one. So I know that M is 2. I'll put the 2 there. I know N is 1. So for experiment 1, the rate is 5 moles per liter per minute is the same. Well, I'll just go ahead and I'm going to rewrite that as molarity per minute. Because remember, molarity is moles per liter. So I'm writing it that way to clean it up just a little bit. That's equal to K, the rate constant. And that's equal to 0.1 molarity squared, 0.1 molarity. And it's redundant to do this, but I'm going to put it here anyway to the 1 power so you guys see where it came from. So then K, rate constant, is equal to 5.00 molarity per minute over 0.1. Now I'm going to 0.1 molarity, whole thing cubed, right? I'm going to separate the numbers from the units now. 5.00 divided by 0.1 cubed times molarity per minute over molarity cubed. Because if I cube this, it's going to be 0.1 cubed and molarity cubed. All right. So let's go here. Get my calculator out. Clear. 5 divided by 0.1 divided by 0.1 divided by 0.1. That gives me 5,000. K is equal to 5,000, and that's 3 sig figs. So 5, 1, 2, 3. That's not 3 sig figs just yet, but I'm going to underline that, telling me that that's my least significant figure as a reminder right here. And then this molarity will cancel out with one of these and make that molarity squared. So I will end up with molarity to the -2 minutes to the -1. And then to get this in correct number of sig figs, 5,000 to 3 sig figs would be 5.00 times 10 to the third. And if I want to put it back, molarity is moles per liter. I can go moles per liter, the -2 minutes, the -1. Okay. Then I'm going to go ahead and rewrite the whole rate law in kind of the format that I told you guys, at least that I'm accustomed to. I would then say that the rate law is R, that's R is equal to K, lowercase k, A to the 2, B to the 1. I'm not going to put the 1 here. You could put the 1 if you want to at this beginner stage. We don't normally put the 1 because it's understood. Where K is equal to 5.00 times 10 to the third moles per liter to the -2 minutes to the -1. Okay. And that's how we would do that. It's okay to do it by inspection the way I showed you by looking at it and saying, I expect to get m equals 2 and n equals 1. But in my class, I am also asking you to show me that you've mastered the math skill set. So on the test, when I leave a blank space, That's what I'm asking you to do, to show me the math. If you don't show me the math, I'm not going to give you the points. Okay. All right. So I hope that helps. And, we'll do some more problems later.